Good evening, dear students.
Good evening, ma'am.
Yes, good evening. So, in the last class, we have started with some basic concepts of chemistry, right? So, starting, we have seen some synopsis part. Okay, so these were the synopsis which we have seen. Okay. We have discussed about atomic mass, molecular mass, and mole concept. Okay. So as you know, from the first chapter, okay, mole concept is very important. So from mole concept, different types of questions are asked. So that we will be solving. Okay. Similarly, let us see how to calculate the equivalent weight. Okay. Do you know what do you mean by equivalent weight? Yes. What do you mean by equivalent weight? Yes, what do you mean by equivalent weight, or what is the formula to calculate the equivalent weight? So equivalent weight of any metal can be calculated by weight of that metal upon how much amount of H2 ions, that is the weight of the hydrogen which is displaced into what is the equivalent weight of hydrogen is 1.008. Okay, you have to multiply by that. So so depending upon that, so these are the different okay. So it is so what we are doing in equivalent weight, okay, with respect to equivalent weight when we speak, so it is nothing but it is a mass of the given substance. Okay, we relate the mass of one equivalent to the mass of the given substance. Okay, so this will be calculated with in the terms of gram equivalent. Okay, gram equivalent weight. Okay, so like that we calculate the gram equivalent weight. So these are the different formulas with respect to the metals. Okay. So with respect to the different metals, we have the metal formula. So if we have, so if it combines, the metal is combined with the oxygen. So weight of the metal upon weight of the oxygen, which is combined into 8. Okay. Because the equivalent weight of the oxygen, okay, it will be 8. Here, so this is it is what? So equivalent mass or equivalent weight, it is nothing but it is equal to the molecular or the atomic mass. Okay, and you have to divide that atomic or the molecular mass by the number of electrons, okay, which are involved in the reaction. So, so this is with respect to the gram equivalent, or you can say equivalent weight. Then how to determine the chemical formula? So to come down to a chemical formula, okay, chemical formula. So how we invent NaCl, NH4Cl, okay, yes, CaCl2, that is calcium chloride, okay, calcium hydroxide, CaOH twice. So these are all the chemicals, okay, these are all the formulas, okay, of a chemical compound. So how to determine this chemical formulas? So to determine the chemical formula, we study something called as empirical formula. Okay, we study something called as molecular formula. Okay, so by this method we are going to come we have to calculate, or we have to determine the chemical formula. Okay, so what is this empirical formula? Empirical formula, it gives the simple whole number ratio. Okay, it gives you what? The simple whole number ratio of the atoms of various elements present in one molecule of compound. Suppose I have NH4Cl. Okay, now NH4Cl, so what it tells you now, what is this empirical formula in this? If I have NH4Cl, okay, it tells you what? Nitro. Okay, what are the okay, so what are the what you can say? What are the atoms present in this molecule? Okay, so in this compound, so nitrogen is present, hydrogen is present, and Cl is present. Okay, it tells you the ratio in what numbers it is present. Nitrogen is present in 1. Okay, nitrogen, 1 atom of nitrogen. Hydrogen's 4 and chlorine is 1. So like this. So this empirical formula is nothing but it gives you a simple ratio, that is N1, H4Cl like that. Okay. So it tells you the simple ratio, whole number ratio of the atoms which are present in the molecule of the compound. Okay. Then next is molecular formula. What does this molecular formula tells you? Molecular formula, it gives you the actual number of atoms, okay, of various elements present in one molecule of compound. Now, so okay, so this is molecular formula. It is determined by multiplying the empirical formula into the number, okay, n. So that we are going to study. So it tells you the actual, it tells you the actual number of atoms, okay, which are present in the compound. Okay. So these are the methods, okay, which we are going to use for determining. Fine. Let us go for the next one. See here you can see what is the relationship between the empirical formula and molecular formula. Just now I told you, whenever you want, what is molecular formula? It is also the whole number, but this is the actual number of atoms which are present. How we have to how we have to calculate? You have to calculate by multiplying the n. Okay, n is any integers that can be 1, 2, or 3 into the empirical formula. Or if you want to find out what is n, n is nothing but the molecular mass, okay, molecular mass upon the empirical formula mass. Okay, so this is about the formula. So please remember this formula. By using this formula, we are going to determine the empirical formula and molecular formula of some compounds. Okay, so what are the steps? Okay, what are the steps to calculate the empirical formula for compound? So first you have to convert the mass percent of various elements into grams. So first step is what? In empirical formula, you have to convert the mass percent of various elements into the grams. Okay. And so 14% means 14 by 100. Okay, so 14 grams in 100. So like that. So 14%. So like that. So if you, whatever the mass percent is there, that you have to convert into the grams. Then convert the mass obtained in one into number of moles. So then you have to take the smallest this, and you have to multiply, divide that, and you have to convert it into the moles. Then divide the mole value obtained in this step, okay, second step, by the smallest mole value. Okay, you have to divide the mole value, whatever you have obtained in the second step, and that you have to take by the smallest mole value. Okay, and if the ratios are in not in whole number ratio, suppose it is 1.2, 1.3, then you have to take the whole number 1. Okay, 2.2, so it is 2, like that. So that you have to take the whole number. Means if carbon, if you have calculated for carbon, if it comes 1.3, so you have to take as 1. Then hydrogen, if it is 3.2, so take it as 3, like that. Okay, so when we are solving, you will understand, but just understand this. So when we are obtaining, okay, when we are obtaining the this what ratio, okay, we are not going to obtain it in the whole number. What you have to convert, then you have to take the particular coefficient, okay, whatever the suitable coefficient is there, in that you have to convert. Okay, and then write the empirical formula by mentioning the numbers after writing the symbol of respective. Means carbon, how many it is? 1. Hydrogen 3, oxygen 3, suppose. Okay, so like that you have to mention the number. Okay, so this was about your empirical formula. So limiting agent and the other things, so let us see later. Okay, so based on this, so let us solve some problems now. So in the last class, we have solved only few problems. Okay, so we have solved only very few problems. Not this. Okay. So let us see. So we have solved, I think, 5 problems, right? Yes, 5 problems we have solved. So let us go for the sixth one. So let us start from the sixth one. Okay. So the problem is a bivalent metal has an equivalent mass of 32. Okay. Bivalent metal is there. What do you mean by bivalent, students? Bivalent means what? Bivalent means metal with plus 2 charge. Okay. Bivalent 2 plus 2 charge. Okay. So a bivalent metal has an equivalent mass of 32. The molecular mass of the metal nitrate is. Yes, how will you do this? So A 168, B 192, C 188, D 182. How you are going to solve this? Any idea? So this is a question on equivalent mass. Okay. So this is a question on what? Equivalent mass. So how are you going to calculate this? Yes, try. So what you are going to do here? So I said bivalent metal means M with the positive charge. Okay. So what they have given, the equivalent mass of this metal is 32. Okay. Of this bivalent metal is 32. What you have to find out? The molecular formula of this metal nitrate. Okay. So M is plus 2. Your nitrate ion is what? NO3 minus. So will you write, please tell me how to write the formula for this now. What will be the formula? Formula. Okay, molecular formula for this particular. I think I have explained you about this in the last class. So when you have, suppose I have NaCl. Okay, I have NaCl. Na will be plus 1, Cl will be minus 1. So I'll write NaCl. Okay, plus 1 minus 1 get cancels. Okay, now I have Ca plus 2 and not Ca plus 2. Let me take other. Then I have NH4 plus and Cl minus. So plus 1 minus 1 cancels. Formula becomes NH4Cl. Okay. Now suppose I have Ca plus 2 and Cl minus 1. What will be the formula, students? Try. What will be the formula for this? What will be the formula? When you have, okay, when you have charges, okay, unequal charges. Okay, when you have unequal charges, what you have to do? What you have to do? You have to write the number. Okay, this is 2. This is 1. So whatever the charge is there on that particular atom, so that you write down, and then you have to crisscross. Crisscross means what? Just cross multiply. Okay. Now Ca into 1 will be Ca and Cl into 2 will be, it will be 2 times Cl2. So the formula will be CaCl2. Okay, formula will be CaCl2. Same way for this. Can you tell me what will be the formula for this now? What will be the formula for this? M is 2. The charge is 2. So write it 2. Here it is 1. So again multiply. So when you have to do this cross multiplication, when you have unequal charges. Okay, remember the students. So whenever you have unequal charge, okay, now here plus 1 is there, minus 1. It will get cancelled. It becomes NaCl. Okay, here plus 1 minus 1 get cancels. It becomes NH4Cl. Now here the charges are not equal. So you have to crisscross or cross multiply. So what it will be? MnO3 twice. Okay. So the formula of the metal nitrate is this. So what you have to do? You have to find out the molecular mass of the metal nitrate. Okay. So this is the question. Okay. I hope you have understood this. Yes. Is it clear up to here? Any doubts? Any doubts up to your students? So this was a question asked in 2009. Any doubts up to here? Okay, so here the metal is in +2 state. Okay, so what you have to do? So the molecular mass is given as 32. So let us find the atomic mass. So atomic mass is what? Atomic mass is molecular mass. Okay, that is equivalent mass. Sorry, equivalent mass into valency. Right, into valency. What is the equivalent mass? Equivalent mass is 32. What is the valency? It is 2. So what is this? 2 2s are 4, 2 3s are 6. So the atomic mass of the bivalent metal is 64. Okay, it is 64. Now the metal nitrate, okay, we have seen the formula of the metal nitrate. The metal nitrate will have the formula of MnO3 twice. Okay, so therefore the molecular mass of metal nitrate is, okay, so what is the metal nitrate molecular mass? Did you find out? Yes, so metal, what is the metal your mass? It is 64 plus, okay, oxygens. How many oxygens are there? 3 2s are 6. 6 oxygens are there. Okay, 6 into nitrogens 2. Okay, 14 plus 14, 8, 28. So 28 plus 16.
92.
No, not this is okay. We are finding out what the mass, right? So here, when we are calculating the molecular mass of oxygen, okay, oxygen is how much? Oxygen is 16. So 16 into how many? 6. 6 6 are 6 7 7. Just see how much you are getting. 3 to the 6. Okay, so if it is 16 into 6, 96. Okay, it will come as 96. See, 96. Are you getting 96? Okay, now you calculate the total molecular
1
mass. 64 plus 28 plus 96, 188. Okay, so our answer is which one?
C.
C. Yes, very good. Okay. Any doubts up to yours? So like this question is asked, it can be asked for a trivalent. Okay, if they ask for trivalent, what do you mean by trivalent, students? Trivalent means metal with 3 plus charge. Okay, 3. So what you have to do? So again, they will give you the equivalent mass. You have to calculate the atomic mass. How you will calculate atomic mass? Equivalent mass into the valency. What will be the valency then? It will be 3. So whatever the equivalent mass will be there, that you take, and the valency of trivalent will be 3. Okay, then they will tell you to find the molecular mass of metal chloride. Then suppose they tell you to find the metal chloride. Okay, so metal will be +3, chloride will be Cl -1. Again, what will be the formula? Yes, what will be the formula? The formula will be MCl3. Okay, so again, put the value of the atomic mass here and put the value mass of the chloride, and you will get the molecular mass. Understood? So like this, the question can be asked. Okay, question type of question will be same, only either they will ask you bivalent, they will ask you trivalent. Okay, so and the molecular mass can be asked for anything. Metal chloride, okay, metal chloride, metal hydroxide, okay, metal hydroxide or metal hydroxide, then your metal nitrate. Okay, so like that, anything can be asked. So just remember, okay, whenever you have unequal charge, if they ask you bivalent and if they tell you chloride, metal chloride, then Cl is -1. So this will be 2, this will be 1, crisscross, it will be MCl2, like that. Okay, so don't get confused. So remember, when you have unequal charge, write the values down, the digits, okay, and crisscross or cross multiply. Okay, you will get the formula. Only when you have to write, when you have to do cross multiplication, when the charges are unequal. Okay, when the charges are unequal. I hope this is clear. Okay, let us go for the next question. Okay, next question is an aqueous solution. An aqueous solution containing 6.5 grams of NaCl of 90% purity was subjected to electrolysis. After the complete electrolysis, the solution was evaporated to get solid NaOH. The volume of 1 molar acetic acid required to neutralize NaOH obtained above is A 2000 cm cube, B 100 cm cube, C 200 cm cube, and D 1000 cm cube. So again, this question was asked in 2009. Okay. So how you are going to solve this? Yes. So what all is given here? So again, this question is somewhat okay of normality. Okay. So again, you have to equivalent that formula you have to apply, and then you have to see. So what all things are given here? Yes. So you have to find what the volume of 1 molar acetic acid required to neutralize NaOH, which is obtained above is. Okay. So first let us find the weight of NaCl. Okay. An aqueous solution containing 6.5 grams of NaCl. Okay. Of 90% purity was subjected to electrolysis. What do you mean by electrolysis, students? What do you mean by electrolysis? Electrolysis means what? Yes. So what is done? Okay. Okay, so suppose a beaker is taken. Suppose a beaker is taken. Okay, in that our NaCl solution is added, which is 6.5 grams of NaCl. Okay, that is added, and this is 90% purity. Okay, the purity of this solution is 90%. This is subjected to electrolysis. What do you mean by electrolysis? Electrodes are placed. Okay, electrodes are placed in the solution and external current is applied. Okay, external current is applied. So what will happen? Whatever NaCl is there, NaCl will break down into Na plus and Cl minus ions. Okay, in water. Again, NaCl, aqueous solution means what? NaCl is dissolved in water. So NaCl will split into Na and Cl minus, and water will split into H plus and OH minus after electrolysis. Okay, after subjecting to electrolysis. Electrolysis means what? The after applying the electric current, the ions, okay, what will happen to the NaCl will dissociate into its ions. Okay, NaCl, the aqueous NaCl will dissociate into its ion. So after completion of this, after no more NaCls are dissociated into Na plus and Cl minus ion, what will happen? Whatever the solution is there, okay, that will get evaporated to solid NaOH, because in the beaker, what I said, Na plus ions are there, Cl minus ions are there, OH, okay, OH because of water, and H plus ion. So what will happen? What will happen in this? Okay, after some time, the solid NaOH is formed. So your Na will combine with this OH, okay, and it will form NaOH. Okay, so after some time, NaOH is formed, okay, after evaporation the solution, because HCl, so HCl will be a gas. So that will escape out and your NaOH will form a solid form. Okay. So what will be the volume of 1 molar acetic acid which is required to neutralize this NaOH? So whatever the NaOH is obtained, so how to neutralize, what will be the volume required? Okay. So I hope the question is clear now. So first let us find out the weight. Okay, weight of NaCl. The weight of NaCl. So what is weight of pure NaCl? Weight of pure NaCl is what? 6.5%. Okay, 6.5 grams in 90%. 90% means 90 by 100. Okay, so 9 by 10. So just see what is the percentage. Yes, 6.5. 6.5 into 9, or it is 0.9. It will be 5.85 grams. Right? Are you getting the same? 5.85 grams. So we have found out the weight of the NaCl. How? 5.6.5 grams in of 90%. 90 means 90 by 100. Okay. Now next is what? Let us find the number of equivalent. Okay. Number of equivalence of NaCl. What is the number of equivalents of NaCl? So 5.85 grams. What is the weight of the NaCl taken? Number of gram equivalent of NaCl is calculated by weight of NaCl upon molecular mass of NaCl. What is weight of molecular? This is taken as 5.85. Okay. So the weight of the NaCl is 5.85. And what is the molecular mass of NaCl? Molecular mass of NaCl is how much? It is 58.5. Okay, it is 58.5. So how much it will be? It will be 0.1. Okay, so what is the number of equivalent of NaOH obtained will be 0.1. So because equivalence of NaOH obtained is 0.1. Why? Because after complete analysis, okay, electrolysis, whatever the NaCl is there, that is converted into NaOH. Okay, because HCl is escape. So the number of equivalents of NaOH obtained is how much? It is also 0.1. Okay, so next is what is the volume of 1 molar acetic acid required? Okay, what is the amount of 1 molar this required? Okay, so therefore normality. So we know the formula N1V1 is equals to N2V2. So this is for NaOH and this is for acetic acid. Okay, so what is the normality of NaOH? Normality of NaOH is 0.1, 0.1. What is the volume of NaOH? So it will be 1000. Okay, it will be 1000 ml. Okay, so 1000 ml of NaOH is equals to, what is the normality of this? It is acetic acid is 1 molar. Okay, and what is the volume? Volume of this acetic acid we don't know. Okay, so we'll keep it as it is. So 0.1 into 1000 divided by 1 is equals to V2. So what is our V2? Yes, 0.1 into 1000. What is the answer? 0.1 into 1000. I'm getting 100. Okay, I'm getting 100 cm cube. So our option is B. Option B is the correct answer. Are you getting the same, everybody? So,
yes, ma'am.
okay. So this is like this, the question is asked. So here we are applying normality also, and we are applying the equivalent weight formula also. So how we are calculating the number of gram equivalent of NaCl by weight of the NaCl upon the molecular mass of NaCl. Okay. Okay, so what is the molecular mass of NaCl? NaCl, Na is 23 plus Cl is 35.5. Okay, if you are getting confused, have you got 58.5? It is 23 plus 35.5. Okay, you will get 58.5. So number of equivalents of NaCl is given as given weight upon the molecular mass of NaCl. Okay, so it is 5.85 divided by 58.5. So that much is the gram equivalent of NaCl, which is equal to NaOH, because after electrolysis, okay, the solution is evaporated to NaOH. So the normality remains the same. So by using this formula, we are going to obtain the answer. Any doubts up to here? Any doubts? Yes. Okay, so let us continue further. Let us continue further. Next question. The amount of heat evolved when 500 cm cube of 0.1 molar HCl is mixed with 200 cm cube of 0.2 molar NaOH is. Yes, so the amount of heat which is evolved. Okay, so what is the amount of heat which is evolved when 500 cm cube? So this is the volume, okay, of HCl. So this is the volume of your HCl, that is 500 cm cube, and the normality of HCl is 0.1 molar. Okay, and so what is done? So this, okay, your 500 ml of HCl, it is mixed with what? It is mixed with 200 cm cube of NaOH. Okay, so this is volume of NaOH. So, and of 0.2 normality, okay, 0.2 molarity. So what is the amount of heat produced? What is the amount of heat evolved, okay, when these two solutions are mixed? So like this is the question. So let us see how we are going to solve this. So here, so what we are going to see, so what is the HCl? Okay, HCl, we are going to find the equivalent of HCl. Okay, equivalence of HCl, equivalence of HCl. So how we are going to find the number of equivalent of HCl? So milli equivalent of HCl can be calculated as, so what is the volume? Volume is 500 into the normality, it is 0.1. So by this, we are going to calculate the moles. So number of moles, it is 500 into 0.1. So that we are going to convert millimoles, we are going to convert into moles. Okay. So just see. So 500 into 0.1. So this is 50. Okay, 50 millimoles. So that I'm going to convert into moles. So 50 divided by 1000. Okay, so I'm going to get the moles. So that is 0.05 moles. So what I've done, 50 millimoles. I got 50 millimoles. So I'm going to convert it into moles by dividing it by 1000. Okay. Now let us calculate the milli equivalent of NaOH. Okay, how we are going to calculate the NaOH milli equivalent? Again, how much volume? 200 into the normality is 0.2. How much is the millimoles? 200 into 0.2 is how much?
40.
200 into 0.2 is 40. Okay, so 40 millimoles. So this 40 millimoles again divided by 1000. Okay, 40 divided by 1000 is how much? I'm converting into moles. So it will be 0.04 moles. Okay. So suppose when 1 mole of H plus ions, okay, when 1 mole of H plus ions and 1 mole of OH minus, okay, OH minus ions are neutralized. Okay, what do you mean by neutralize? Neutralize means when your acid and base reacts to give you salt and water, it is called as the neutralization reaction. So 1 mole of H plus ions and 1 mole of OH minus ions, they will neutralize. Okay, so 1 mole of water is formed. So when H plus and OH minus 1 mole are combined, they are neutralized. What is formed? 1 mole of water is formed, which is 57.1 K. 57.1 K. Okay, it is 57.1 K. So which is the water. Okay, this is the amount of heat of water. Okay, this is the amount of heat or the energy which is released. Now again, so same. So this is with respect to 1 mole. Now what we have seen here, when you have 0.04, right? So when you have 0.04 ml of, that is your moles of H plus ions, sorry, 0.05 moles of H plus ions when they react with 0.04 moles of OH minus, then how much it is? You have to 0.04 into 57.1. Calculate how much will come. So you have to multiply this particular mole value with the energy. Okay. Just see how much you are getting.
Ma'am, 2.284.
Okay. So let me check. So 57.1 into 0.04. Okay, yes, 2.284. So our answer is nearer to what? Our answer is nearer to option number A, right? Our option number A. So what we have done, we have found out the first step is what? We have found out the milli equivalence. Okay, we have found out the milli equivalence of HCl, because from HCl we are going to get H plus ions, and from NaOH we are going to get the OH minus ions, right? So together what we are going to get, that is water, H2O. So when 1 mole of H plus ions and 1 mole of OH minus ions are neutralized, how much amount of energy is released? 57.1 kilojoules of energy is released. So when 0.04 moles of energy is okay, when 0.04 moles of this is combined, so that you have to multiply the amount of energy which is released, that is 57.1, you are going to get 2.28 or 2.29 kilojoules. So this is the amount of heat evolved when your these solutions are mixed. Okay, when 500 cm cube of HCl is mixed with 200 cm cube of NaOH of 0.1 molar HCl and 0.2 molar NaOH. Okay, is it clear? Is it clear up to here? Okay, so let us go for the next question. So our next question is, a mixture of calcium chloride and NaCl weighing 4.44 grams is treated with sodium carbonate. Okay. Solution to precipitate all the Ca plus 2 ions as calcium carbonate. The calcium carbonate so obtained is heated strongly to get 0.56 grams of calcium oxide. The percentage of NaCl in the mixture is, so atomic mass of Ca is given, which is 40. Okay, so how to solve this? So let us see the reaction. Okay, we will write the reaction, how it is given. Then we will come to know. Okay, so understand the question once again. A mixture of calcium carbonate and NaCl, okay, is weighing 4.44 grams. A mixture of calcium chloride and NaCl weighing 4.44 grams is treated with sodium carbonate solution to precipitate all the Ca plus 2 ions as calcium carbonate. The calcium carbonate so obtained is heated strongly to get 0.56 grams of calcium oxide. The percentage of NaCl in the mixture is, let us write the reaction. So what is the reaction? So what is happening? All the calcium carbonate, okay, what is done? The calcium carbonate, okay, it is heated. Okay, it is heated strongly to get you calcium oxide. So calcium carbonate, when you heat it, what will happen? You will get calcium oxide plus this is released. Okay, carbon dioxide gas is released. So what is the calcium carbonate? Okay, if you see the calcium carbonate here, so can you find out the molecular mass, students? Find out the molecular mass here. Calcium is 40, carbon is 12, each oxygen is 60. Just find out. Yes, find out the weight of calcium carbonate and also calcium oxide. Calcium is 40, oxygen is 16. Yes, 40 plus 16 is 56 grams. Okay. Can you tell me of calcium carbonate? Yes, calcium is 40, carbon is 12. Find out. Oxygen is 16 into 3. How much you are getting? 100 grams. Are you getting 100 grams, students? So 40 plus 12 plus 16, 16 and 16. Okay, 3 oxygens. So you have to get 100 grams. So when 100 grams, okay, 100 grams of calcium carbonate heated, you get 56 grams of calcium oxide. So this is the okay, this is the relation. Now how much amount is, so if 56 grams, okay, so from this if we understand that 56 grams of calcium oxide is obtained, okay, when we are obtaining 56 grams, obtain when 100 grams of calcium carbonate. It is obtained from what? Your 56 grams is obtained from 100 grams of calcium carbonate. Okay, so what they have asked, they have got 0.56. So 0.56 grams of calcium carbonate is obtained from how much? X. So it will be 100 into 0.56 divided by 56. Just see how much you're going to get, students. Okay, just cross multiply. Cross multiply. So 100 into 0.56 divided by 56. Just see what will be your answer.
1.
Okay, let me see. 100 into 0.56 divided by 56. Yes, 1. Okay, I got it as 1. So 1 gram of calcium carbonate. So calcium, if 1 gram of calcium carbonate is heated, I am going to get 0.56 grams of your calcium oxide. So this first we have found out. Next step is what? So from this, we know that what we know. So let us write the next relation. So what all is heated? So calcium chloride is heated with what? A mixture of calcium chloride and NaCl is weighing 4.44 grams, right? So is heated with sodium carbonate. So what I'm going to do? So calcium chloride is heated with your sodium carbonate, that is Na2CO3. Okay, to give you what? To give you calcium carbonate plus 2 NaCl. Okay, so they have asked you to find out the percentage of NaCl. Find out the molecular mass of calcium chloride. Calcium is 40, chloride is 35.5 and 35.5. Find out. Calcium chloride, what is the weight? 35.5 plus 35.5 plus 40. 111. Okay, 111. Then
Yes, ma'am.
111. So from if 111 grams of calcium chloride reacts with your sodium carbonate, you get 100 grams of calcium carbonate. Okay. So if 100 grams of calcium carbonate is obtained, it is obtained from by 111 grams of calcium chloride. Okay. So 1 gram of calcium carbonate, how much is calcium chloride obtained? Okay. So obtained by how many grams of calcium chloride? So again cross multiply. So 111 into 1 divided by 100. Just see 111 divided by 100.
Ma'am,
1.11. So what we are going to find out now? Yes, we are going to find out the percentage of NaCl. How this NaCl is obtained? See here, when calcium carbonate, okay, calcium carbonate, when it is treated with sodium carbonate, it will give you what? It will give you calcium carbonate, okay, and NaCl. So by this relation, we are going to find out. So from calcium carbonate, further what we have obtained? Calcium oxide. So that we have understood. We had what? We had calcium oxide. So from calcium oxide, we found out how much grams of calcium carbonate could be obtained. That was 1 gram. So from 1 gram of calcium carbonate, we obtained 0.56 grams of calcium oxide. So this we got. Now from this, what we are going to find? We are going to find out NaCl. First again, no, calcium chloride. So from 100 grams of calcium carbonate, okay, from when it is obtained? From 111 of calcium chloride. So from calcium carbonate, okay, we are obtained 100 grams. So from where we have obtained this 100 grams? From 111 grams of calcium chloride. So to obtain one, so in the last, okay, we have seen. So from 1 gram, we obtain 0.56 grams of calcium oxide. Okay, so from 1 gram of calcium carbonate, we obtain 0.56 grams of calcium oxide. So we are going ulta. Okay, we are going reverse. So now what we are going to find out? So for 1 grams of calcium carbonate, okay, it is obtained from how many grams of calcium chloride? So what we are going to do? We are going to do cross multiplication. So 100. So we are going reverse. Okay, we are going reverse. So 111 into 1 divided by 100 is 1.11. So 1.11 grams of calcium chloride. So from 1.11 grams of calcium chloride, we are going to obtain 1 grams of calcium carbonate. Okay. So now what all we have seen? So weight of the NaCl. So weight of NaCl is how much? So weight of NaCl is your weight of NaCl is how much? So what we have seen, so calcium chloride plus Na2CO3 giving you calcium carbonate plus NaCl, right? So what I'm going to do? What is the total weight of NaCl? 4.44. So from 4.44, if I minus 1.11, okay, this is the weight of, because the total, what they have said, the mixture of calcium chloride and NaCl is weighing 4.44. So from this, we are going to find the percentage of NaCl. So 4.44 is what? It is the weight or total weight, okay, of the mixture. So from this, I'm going to subtract the weight of the calcium chloride. So I got 3.33 grams, okay, 3.33 grams. So if I want to find the percentage of NaCl, how is the percentage? So 3.33 divided by 4.44 into 100. Find out the percentage now. Okay, so out of 4.44, 3.33 grams is of NaCl. So 3.33 divided by 4.44 into 100 is the percentage of NaCl. That comes to be 75%. Okay, that is our option number A. So what all things are given here? Okay, a bit confusing question. So what they have asked, they have given a equation. Okay, so I'll just tell you. So calcium chloride is there. It is reacting with what? Sodium carbonate, and it will give you calcium carbonate plus NaCl. Now, what are the things they have given? They have told NaCl2 plus that is calcium chloride plus NaCl. The total weight is 44.44 grams. Out of this, they have told you to find the percentage, okay, percentage of NaCl. So how to find out? Now what we have? We have the this what weight of the calcium oxide. Now in this step, do we have calcium oxide? No. How did we get calcium oxide? again, next step. So from this calcium carbonate, what they did, they heated. Okay, then we got calcium oxide plus carbon dioxide. So what we did, so we found out that from 100 grams, okay, from 100 grams, we can obtain 56 grams. Okay, from 100 grams, we can obtain 56 grams of calcium oxide. Uh, so from 0.56 grams, okay, how much grams of calcium carbonate is obtained? So from this, we got the weight of the calcium carbonate. Okay, that was 1 gram. So from this 1 gram, next step what we did, we found out what? So from 1 gram, again, from 100 grams of calcium carbonate, we can obtain 111 grams of calcium chloride. Okay, so from 111 grams of calcium chloride, we can obtain 100 grams of calcium carbonate. So how much amount of calcium carbonate chloride is obtained from calcium? 1 gram of calcium carbonate. Again, ulta. Okay, reverse. Again, cross multiply. So from this, what we got? We got 1.11 grams. Right, right. So what we did, the total weight. What was the total weight? Total weight was 4.44. So from 4.44, we subtracted because calcium chloride plus NaCl. So from this, we subtracted the weight of the CaCl2, that was 1.11. We obtained 3.33. So this was the weight of the NaCl. Okay, so we want percentage. Percentage, so the given weight upon the total weight into the 100%. So we got 75%. Is it clear now? Okay, simple question, but they have asked little, okay, very deeply. So very in reverse form they have asked. So we have to go from back. We are doing here reverse method. Okay, so from calcium carbonate, okay, we are going to obtain the weight of calcium oxide. From calcium oxide, we are going to find the weight of calcium carbonate. From that, we are going to find of calcium chloride. Then we are going to subtract and we are going to get the weight of the NaCl. Is it clear? Please solve this. Okay, if you did not understand, solve this. So again, it will be clear. Okay, it will be more clearer. Bit confusion will be there because they have asked in a reverse. We have solved it in a reverse manner. Okay, is it clear? Fine. Okay, so the remaining questions, okay, so we shall be doing it in the next class. Okay, because already it is time up. So the remaining questions, let us do it in the next class. Fine.